Quantum Mysteries Revealed. Does reality depend on us? Welcome to Final Frontier, where today we're diving deep into one of science's most puzzling questions. What is the true nature of reality? Quantum mechanics reveals a universe that's fundamentally different from anything we experience daily. So let's start by imagining this. Imagine a magical box. You ask it for an apple, a pencil, or even a unicorn, and voila, it appears. But here's the twist. The box doesn't decide what to create until you open it and look inside. Before you open it, all those possibilities exist at once. This idea mirrors one of the weirdest aspects of quantum mechanics, where particles don't choose a state until observed. Let's explore what that means and why it's so mind-bending. What quantum mechanics tells us about observation and reality. In quantum mechanics, particles exist in a superposition, meaning they can be in multiple states simultaneously. It's only when we observe them that they collapse into a specific state, like the apple, pencil, or unicorn appearing in our magical box. This phenomenon, known as wave function collapse, suggests that reality as we know it could depend on us. One interpretation, the Copenhagen Interpretation, claims that observing a particle is what makes it take a definite state. To make sense of this, let's use an example. Schrödinger's cat, a thought experiment where a cat is in a box with a poison vial triggered by a radioactive atom. Until we observe, the cat is both dead and alive. When we observe, it's one or the other. It's a strange idea, but this quantum weirdness has been tested in real experiments and is fundamental to how particles work at tiny scales. If you're finding this fascinating, be sure to hit the like button and subscribe. At Final Frontier, we're always uncovering the mysteries of the universe, and we don't want you to miss a single discovery. Atoms and the fundamental nature of reality. Let's move from particles to atoms. We know atoms are the basic building blocks of everything, from the chair you're sitting on to the stars in the sky. But atoms aren't the smallest particles. They're made up of electrons, protons, and neutrons, and each of these has its own set of even smaller parts like quarks. But even more profound is that these particles might not be particles at all. They're excitations in quantum fields, meaning everything in the universe, including you, is just a bunch of vibrations in an invisible field. In the quantum world, predictability as we know it doesn't exist. The famous Heisenberg uncertainty principle tells us that the more precisely we measure one property, like position, the less we can know about another, like momentum. Reality at this level is probabilistic, meaning we can't predict with absolute certainty what will happen, only what's likely to happen. This forms the core of quantum theory, a world that's probabilistic, where even the location of particles is just a matter of probability until measured. The role of observers and consciousness in quantum mechanics. Now, here's where things get philosophical. What does it mean for a particle to be observed? Do we, as conscious beings, play a role in shaping reality? Some interpretations suggest that it's the act of observation by a conscious being that causes the wave function to collapse. Others, however, argue that even inanimate objects like detectors can cause collapse, indicating that consciousness might not be required at all. Still, the question remains, can reality exist without observation? And if not, does this mean that the universe only exists because we observe it? This is where the many worlds interpretation comes in, suggesting that all possible outcomes actually happen, but in parallel universes. When a particle's wave function collapses, it doesn't just choose one path, but all paths, each in a separate universe, the block universe and timelessness. Einstein's theories take us even further into this mystery. According to the concept of space-time, all moments, past, present, and future, exist simultaneously, like frames in a film reel. In this block universe theory, our perception of time flowing from past to future might be just that, a perception. This implies that past moments, where loved ones lived, still exist and haven't truly disappeared. Einstein's theory of relativity suggests that time is relative. It's tied to our experience but not absolute. Some physicists propose that this means we might never truly lose anything in time. Instead, everything exists within space-time, just in different slices. It's a comforting idea that suggests that perhaps our connections to the past are not as severed as we might think. Quantum physics and the question of ultimate reality. So what's real and what's just perception? Quantum mechanics pushes us to think beyond our daily understanding of cause and effect. The universe at this level doesn't follow the clear rules we see in the everyday world. For instance, particles can act like waves, and waves can act like particles, a phenomenon called wave-particle duality. Observing a particle affects its state, and particles can exist in multiple states until observed. It's as if the quantum world is governed by a set of rules that are fundamentally different from anything we experience daily, which is why it feels so strange. Quantum physicists have developed multiple interpretations to explain these phenomena, from the Copenhagen Interpretation to the many worlds interpretation, but none can be proven or disproven. They're all equally valid within quantum mechanics, meaning the universe is more mysterious and strange than we might ever fully understand. Quantum mechanics challenges everything we know about reality, time, and our role in the universe. From particles that don't exist until observed to a universe where past, present, and future exist simultaneously, the cosmos is more complex and layered than we ever imagined. And as physicists continue to explore these mysteries, we're left with questions that straddle the line between science and philosophy. Are we just observers, or do we help create the reality we experience? Thank you for joining us on this journey through the quantum world. If you're as fascinated by the mysteries of the universe as we are, make sure to like, subscribe, and hit the bell icon to stay updated on all our explorations into the unknown. See you next time on Final Frontier.